Welcome to VINDAL'S Concepts. For all my friends who are preparing for their exams, I'm wishing you luck, and my way of doing that is to bring you this very special and good topic, simple AC circuit. And I have a question for number one, and if you check very well, if you look at this very well, is Waec 1993. So this is number one question, right? Okay, the question says that the current I in an AC circuit is given by 100 pi. There should be pi here. Is given by, deduce the following from the equation: the frequency, the peak value of the current, the RMS value of the current. Okay, I want us to first understand that whenever we talk about AC circuits or we talk about AC current, we know that such a current of an AC is a sinusoidal graph such that it goes this way. This is the kind of graph an AC current has, whereby this highest value is called the peak current, just like a sine graph. And if you want to know more about sine graph, I have uploaded series of videos. Go to the playlist, you see sine graph equation or sine equation, where we did phase shift, vertical shift, period of graph, and all the rest of them. So this is current in ampere. So the highest from here to this place is called the amplitude, and this place is the origin. And depending on the period, you know what is period, the time it takes to make one oscillation. And like this is our oscillation, maybe we can call it 2 pi or 360 degrees, because remember, angle is mainly measured in radian, not in degree. So this is how AC current is all about. And because of this, remember the wave equation, which is also sinusoidal. And in that being said, this is an angle. Sometimes it can also be measured with respect to time. It can also be measured with respect to time. It can also be measured with respect to angle. Therefore, the current on the vertical axis, which is this one, is equal to, there must be a peak voltage, which is going to be the coefficient of sine. This current, which I've told you, is this one, which I am presenting as this, and this I is the maximum displacement of the current from the origin, is I naught, which is called the amplitude. And the sine of the angle, remember, angle can be measured in this angular frequency or angular velocity, and then the horizontal axis, which is time. So for that being said, also remember that omega can also be given as 2 pi multiplied by the frequency. Now, this is what it is. Also remember that, so what I'm saying in essence is that this is the equation of a sine function or sinusoidal graph. Any kind of concept in physics that goes sinusoidal or that has this kind of graph, which I can call you like wave, transverse wave has this one, all alternating current has this kind of graph, and many other branches of physics, or all the electromagnetic wave. Now, because of that, this is the equation, this is the general equation of this, without considering the phase angle or the difference of the phase angle. Now, if you look at very well from this equation, you see that this is the question you have given. So if I compare this, if you look at this, I have written is equal to I naught, which is the amplitude, then sine omega t. All right, you will realize that it is very similar to this one, to the one that they gave us in the question. The one they gave us in the question, which is 100 pi t. All right, so if you check very well, you see that something is looking like something, and at this point we are going to do a kind of comparison. We are going to do a comparison. If you check very well, where t is in seconds and they deduce the following, the frequency, they say we should deduce the frequency. Now for me to deduce the frequency, remember I have made this conclusion, therefore everything here is going to be comparing it with everything here. All right, and everything here I naught is going to be compared with this 30. Therefore I'm going to simply say that if I equate the two of them, if I compare them, not really equating them, comparing, if I compare them, compare equation 1, this is equation 1 and this is equation 2. If I compare them, you realize that the peak value of the current, let me change the color of my marker for you to see. So you can see that I have already found the peak value current, because I told you that I naught is same thing as I, and is already 30 ampere. Okay, so let's go to finding the frequency. So I'm going to clear and going to tidy up this place, right? Okay, so remember what I was saying. So I'm going to say that omega is compared to, okay, yes, okay, let me carry everything. Let me carry everything there. I'm going to carry omega t is equal to 100 pi t. You see, I'm carrying everything in front of the sign, everything here in front of this sign in the first equation. I'm equating it with everything in front of sign in the second equation. So if that is done, I am going to simplify by doing this. I'm going to say that t will cancel t, they will divide each other, and they will cancel out. So I will have omega is equal to 100 pi. All right, remember what I'm looking for. I'm trying to find the frequency, but remember what I told you before. This omega is something as 2 pi f, and that is equal to 100 pi. Okay, now remember also what I have been doing is I love to do this. Since pi is on this side of the equation and pi is on this side of the equation, they will cancel because they will divide each other. You can, another way of saying it is dividing both sides by pi, and when you do that, let me tidy this one, this side I have, and when you do that, you are going to say that, I love this color so much, I'm going to have that 2f is equal to 100. All right, f is going to be 100 divided by 2, and the frequency is going to be 50 hertz. That is the number one. I have finished solving number one. Like I told you before, I have found number two. Number three, they say I should find the peak, the RMS value of the current. Remember, the RMS value of the current is the effective current, effective current of an AC circuit, which is also seen is the value of the steady current, which would dissipate heat at the same rate in a given resistance. And that RMS value of a current, RMS, is given as peak voltage. I will maybe in subsequent class I will tell you how this, and this RMS value, like I said, this RMS value occurs when when the instantaneous current, I mean what I'm trying to say, that this RMS value occurs when the instantaneous current or voltage flowing an AC circuit has phase angle of 45 degrees. RMS value can be obtained. So what I'm saying is, remember the equation I wrote. If I have this current, this is the instantaneous current, is equal to this sine 45 degrees. I mean, when I'm trying to use angle to do this, if you can do this, if you can solve this, you can now find that the current, this current, instantaneous current, can be likened to be the RMS value current. So at this point, which is equal to I naught, remember sine 45 is something as 1 over root 2. So this is how this RMS current came into existence. All right, let's go back to what we are doing. So at this point, I'm going to multiply. I'm going to have that RMS current is equal to I naught. I found peak value of the current to be 30 divided by root 2, right? 30 divided by root 2. I can simplify it by rationalizing, multiply the numerator by root 2, multiply the denominator by root 2. So this root 2, so this is going to be 30 root 2 all divided by 2. You know why? Root 2 times root 2 is 2, so this divided by this is going to be 15 root 2, and that is the answer. Or 15 root 2 is something as, so I can say that RMS value, so the current, RMS current is going to be 21.21 ampere. Thank you for being part of this class. Remember to always come back, subscribe to this channel, like this video, comment and tell me what you learned. Bye.